Okay, so what we're doing today is the surface area and volume of spheres. Okay, so the surface area formula for a sphere is 4 pi r squared. So the only measurement you have to figure out is the radius, so that's not that bad. And then the volume for a sphere is 4/3 pi r cubed. So again, the only thing you got to find is the radius. So these are relatively easy formulas. Remember, for volume, it's going to be units cubed, and for surface area, it's going to be units squared. Okay, so let's take a look at some examples. Okay, so for number one, again, one of my strategies that I always try and do is I try and write the formulas. The more you write the formulas, you will have them memorized. Okay, and then you're more comfortable with them. All right, so for both of these, I'm given the diameter because it goes all the way across, but I need the radius. And so if your diameter is 12, your radius is 6. And so now I'm just going to plug them in. So that's 4 times 36, which is 144. Oops, I need another 4 there. 144 pi inches squared, and that's the surface area. And then over here, 4/3 times pi times 6 cubed. So 6 cubed is 216. And then if I times that by 4, I get 864. And then divide by 3, so it's 288 pi inches cubed. Okay? So those are basic surface area and volume. For my second shape, I don't have a whole sphere. I have what's called a hemisphere, where it's half. And so let's see, the surface area, I'm going to split this up, is going to be, I'm not even writing the right thing, 4 pi r squared. But that's for a whole sphere. I only have half a sphere, so I'm going to divide that by 2. But then what you should recognize and what you have to realize is that you also have this great circle here. So you have to add the outside to that surface area of that circle. And so what I'm going to do, if I can get this to work, is I'm going to have to add the circle, which is pi r squared. So this is a more complicated thing. I don't want you to try and memorize it. I want you to look at the picture and understand what's going on. So because I had half of a sphere, I take half of the surface area. But then I also have to add this base, and this base is that pi r squared. Okay, so it'll be 4 pi times 11.2 squared divided by 2 plus pi times 11.2 squared. So that ends up being 2 times 11.2 squared, which is 250.88 pi plus 11.2 squared, which is 125.44 pi. And then I add those together, and I get 376.32 pi, and it's meters squared. So this one is a more complicated one, but I think it's still something you can do. You just need to recognize what pieces you have to find the area of. Okay, so I'm going to change colors and do volume now. Volume is 4/3 pi r cubed. And again, I only have half of it. So I'm going to take that volume and I'm going to divide by 2. So I'm going to find this volume first, and then when I'm done, I'm going to divide the answer by 2. So it'll be 4/3 times pi times 11.2 cubed. So let's see, when I do all that together, I get 1873.24 pi. And then I divide that by 2 because it's only a hemisphere. It's half of that. And so the volume is 936.6 meters cubed. Okay? And we don't have to add that great circle for volume because volume is the amount of stuff that fits in it. And so it doesn't matter what the lid is or the top of it is, what shape it is. We just have to find how much fits in it. Okay? All right, so 3 and 4 are some problems we're going to be solving backwards. And so we need to look and see what we're given. We're given the surface area. So if we're given the surface area, then I'm going to write my surface area formula. So my surface area for a sphere is 4 pi r squared, and I have 144 pi. So 4 pi r squared. So I'm solving for the radius because that's my variable left. But if you notice, it's going to want the diameter. So we're going to have to do something at the end. Okay, so I'm going to divide by a 4 pi on both sides. They cross off on the right, and then the pi's cross off on the left. So it's 144 divided by 4, which gives me 36. So r squared is 36. To get rid of a square, I take the square root. So r is 6. And now I need to find the diameter. Well, remember, radius goes halfway across the circle, so the diameter is the radius times 2. And so my diameter is 12 centimeters. And that's it. So what I'd like you to do is I would like you to read number 4, see if you can figure out what the formula it is you need, and then start plugging stuff in. If you're comfortable solving, go ahead and solve. But if you're not, just go ahead and at least plug it in. Okay, the hope is that you recognize you're given the surface area, so I have to manipulate my surface area formula. Now, it does have volume also, but that's what you're wanting to find. We're going to find the volume at the end. But first, we need to solve for the surface area. Okay, so I plugged in my numbers, and now I'm going to divide by 4 pi. And when I do that, I get r squared is equal to 64. And so to get rid of a square, I square root, so r is 8. And so now I'm going to find the volume, which is 4/3 pi r cubed. And so it's going to be 4/3 pi times my radius, which I found right here was 8 cubed. Okay, and I know that 3 is not going to go into either of those, so I'm going to keep mine as a fraction. So I'm going to have 2048 over 3 pi inches cubed. But if you really don't like that, you can go ahead and divide by 3, and you're going to get 682.67 pi inches cubed. Both of those answers are acceptable. It just depends on what you prefer. Okay. All right, one last problem, and that is a composite problem. So what you have to do is you have to figure out what you have. So I have a hemisphere on the left, and so that's going to be 4/3 pi r cubed, but then I'm going to divide that whole thing by 2. And then on the right, let's change colors, we'll do different colors. On the right, I have a cylinder, and the volume for a cylinder is the area of the base times the height. And remember, your base is pi r squared times height. So I'm going to go ahead and do this one first. My base is this circle, and the radius of that circle is 9, and the height is right here. It's how far the bases are apart from each other. So I'm going to times that by 14. So 9 squared times 14 is 1,134. So there's the cylinder. Now let's go back to the hemisphere. And so the hemisphere is 4/3 pi. Now, it's the same radius. It doesn't matter that it's on the other side because it's a cylinder. Both bases are the same. And so if the radius on the right was 9, my radius over here on the left is also 9. So then I'm going to do 9 to the third. So 4 divided by 3 times 9 to the third is 972. But again, remember, that's for a whole sphere, so I got to divide that by 2. So now I divide by 2. And I get 486 pi. Well, these two shapes are put together. They're like stacked on top of each other, so I'm going to add them. So it'll be 1,134 pi plus 486 pi. And so let's see what I get when I add those. I get 1,620 pi, and it's volume, so it's yards cubed. Okay? Again, if somehow that hemisphere was sitting inside the cylinder, I would subtract. But because they're stacked on top of each other, you add. And I guess just wrapping up, I think the biggest thing you need to do for these notes, again, is to write the formulas. And once you write the formulas, you can plug things in, and that makes it easier.